Alright, looks like we have another system of equations involving three unknowns and three equations. You know, if I look at this, if you notice this middle equation here has an x in it, and the top equation has a 2x, and the bottom equation has a 4x, let's go ahead and concentrate on eliminating x from two of the equations. So what I'm going to do is sneak in here, multiply this second equation by minus 2. Alright, so to the right here I'm going to have negative 2x plus 8y minus 12z, and that's going to equal 32. So what I'm going to do is just transfer over this equation to the right. Alright, let's see what that gives us. This is just going to be 2x plus 3y plus 2z is going to equal negative 14. Let's go ahead and add these two together. Of course, the x's cancel out. This becomes 11y minus 10z. And of course, 32 minus 14, what would that give us? 18. Alright? So now we've reduced the first and second equation to 11x minus 10z is equal to 18. Alright, so now let's go ahead and let me erase this. Let's take this middle equation now. I'm going to erase this negative 2. Let's go ahead and multiply this second equation by, in this case, negative 4. I'm going to go down here. So this becomes negative 4x plus 16y minus 24z equals 64. Alright, so again, that's the middle equation multiplied by negative 4, which yields this here at the bottom. Alright, now I'm going to bring this equation, which is here, down below here. So this will become 4x minus 5y minus 2z, and that's going to equal 18. Let's go ahead and add these two equations together. X's go bye-bye. So now we have 11y minus 26z. And this is going to equal 82. Alright? So now if you notice, let me change colors here so we can see pretty clearly. Alright, if you notice now we have this equation and this equation, which of course are two variables, which is two unknowns and two equations. So I'm going to write these over here to the left. So this becomes 11y minus 10z equals 18. And then of course over here we have 11y minus 26z equals 82. Alright? Now let's go ahead and if you look at this, let's multiply this equation by negative 1. So this equation here by negative 1. Alright, so what I did is I went ahead and multiplied this equation by negative 1, and I moved it up this way, and I just moved this equation up without really altering it at all. Alright, so let's add these two equations together. So mainly let's add this equation and this equation together. If you notice, the y's cancel out, and this becomes negative 16z is going to equal 64. So if I divide both sides by 16 here, or negative 16, I get z is equal to a negative 4. Alright, so let's go down here at the bottom. Our ordered triple is going to be z equals negative 4. Now, since I know z is equal to negative 4, which is right here, I'm going to substitute it back into either one of these two equations here, either this one or this one. I'm going to pick the first one. So this becomes negative 11y plus, and of course negative 4 times 10 gives us negative 40 equals negative 18. Okay, I ran out of room here, so let's try to squeeze this negative 18 in here. Okay, so if I solve this for y, this becomes negative 18 plus 40, which is right in here. So negative 18 plus 40 is going to give us 22. Okay, so negative 11y is equal to 22, and of course y in this case, if I divide both sides by negative 11, I get negative 2 for y. So y in here is going to be negative 2. Okay, so this was negative 11 y is equal to a negative 22. So y is equal to a negative 2. Then of course now I know y and I know z, so I can go back up into either one of the original equations. Let me erase this so you guys can see this. Alright, so again, I know. Alright, so if I go ahead and set this equal to negative 14, if I can squeeze in here, negative 14. Okay, so if I solve this, I get 7x. This is going to be minus 6 minus 8 equals minus 14. So 7x minus 14 equals minus 14. So 7x is going to equal 0. So x is going to equal 0. All right, so then we have our three ordered pairs: 0, negative 2, negative 4. And of course we can always check these by plugging them back into either one of the original equations, which are headed up here, and I'm sure you'll find that they do in fact work. Alright, thanks a lot. If you have any questions, this will be on YouTube. Have a nice day.